So in section 5.1, we're really just talking about area and perimeter. And I know area and perimeter is something that you've probably done in the past, but really the main focus of this section is to be able to understand where the formulas come from. So we're going to start by looking at two examples, a blue rectangle and a red rectangle. And we're going to first just count the units that are around the edge of the blue rectangle. So we're going to start up here, and we're just going to count 1, 2, 3, 4, 5, 6. So there are 6 up here. And then 1, 2, 3, 4. There are 4. So far we have 6 plus 4, which is 10. And then we should have another 6 down here at the bottom. And then another 4 over here. So the total for my blue rectangle is going to be 20 units. For my red rectangle, I have 1, 2, 3, 4, 5, 6, 7, 8, and then 3, and then 8, and then 3. So that's a total of 11, and another 11, which is 22 units. Now what you might want to do is just take notes as we go along here, because you're going to be using this information in class tomorrow to complete an assignment. So it might be helpful to have some notes available for you to look at. So what you just did in exercises 1 and 2 is you found what's called the perimeter. It is the area that goes around, and I like to pull this word here, it goes around the rim of the figure, perimeter. And it's basically the distance, the formal definition is the distance around the rectangle. Now we do have a formula that we can use for this, and my formula is again represented by 2 widths and 2 heights. And if I add those 2 widths and those 2 heights together, so there's 1, 2 widths, and 1, 2 heights, then I will get the perimeter of the figure. So therefore my formula is I take 2, which they use actually base instead of width, which you can use width if you'd like to. And I take 2 heights and I add them together. Therefore my formula to find the perimeter of a rectangle is P equals 2B plus 2H. Now let's talk about area. When we talk about area, we're looking at how much is covered by the figure. So I'm going to literally just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have a total of 24 squares inside the blue rectangle. Now, for the red, I have 1, 2, 3, 4, 5, 6, and I can keep doing this until I get up to, again, 24. Now, you'll notice that both of these rectangles have the same area. But when I looked back at perimeter, did they have the same perimeter? The answer is no, they had different perimeters. We're going to be talking about that in just a minute. Now, I always want to represent area in terms of units squared. And the reason why I do that is because I am also multiplying the units when I do my multiplication. Because in order to find the area of a figure, I want to multiply the base times the height. So I always have square units. So in this case, I have 1, 2, 3, 4, 5, 6 columns of 4. Or I can say I have 4 rows of 6. Over here, I have 3 rows of 8, or 8 columns of 3. The formal definition of area is the number of non-overlapping squares that exactly cover the interior of the rectangle. So your squares should not overlap when you find area, and you want to just count how many squares you have for area. Now again, my formula is I take the base times the height, which is your definition of multiplication. It's basically repeated addition. So if I take 4 and add it together 6 times, then I can say that I am multiplying. And that is why I multiply base times height. Now, when I want to find the sum of areas, then I just take the area of whatever region A I'm looking for and whatever region B I'm looking for, and I add them together. I take their sum. So if I have a rectangle, and then I have a square that is attached to that rectangle, then I can say that area A plus area B is equal to the total area. And that is just a postulate. It's something that we don't need to prove, but it's kind of just already given to us. Okay, let's take a look at a concept. In this case, it's called maximizing our area. Okay? So, to look at maximizing area, I'll let this load here. Okay? To maximize area, basically I'm looking for if I had a set amount of perimeter, then what dimensions of a rectangle would produce the greatest area. Okay? Now I'm going to show a graph here, and you should recognize this graph as a parabola from Algebra 1. And where would be my maximum? Because here, so this case, the y is my area, and the x is my base. So the top point here would be considered my maximum area. So we want this big dot right here to slide until it comes up here. Okay? So let's take a look and see what would happen if I make my base greater. And you can see the area changing right here. Is that dot moving in the direction we want it to? Is it moving towards the maximum? No, and as you notice, look how small my area is getting as I'm increasing the base. Now, let's go the other way. Notice that my area is increasing as I'm sliding the base smaller, and notice it's automatically changing the height for me because I want my constant perimeter to be 20. And what value do you notice gets us to the top of that parabola? This keeps changing every time. Okay. But as you can see, it's 5 here. It just keeps changing on me each time. But it is going to be 5. And what is your height when the base is 5? It shows you that your height is also 5. There we go. So what kind of figure is that rectangle? And your rectangle is, of course, a square because both the base and the height are the same. So we find out that in order to maximize your area with a set perimeter, move this up here. Alright, I think I got it fixed here. So to maximize area with a set perimeter, create a rectangle that has the same base and height. Okay? So looking back at our example here that we started with, both of these rectangles had an area of 24. Okay? Both of them had an area of 24. It was just dependent upon what I wanted when you have a set perimeter, You want your area to be the greatest, and a square will create that. Okay? So a square will give us the maximum. Now, what about if I want to minimize perimeter? So I want to get the smallest perimeter, but I want to keep my area constant. So my area is going to stay the same here. We're going to show the curve again. Okay? And I want to minimize my perimeter. So again, if I'm looking at the curve of this figure, my y value is my perimeter, and I want it to find out where it's the smallest. So I want to know what the dimensions of this rectangle are in order to get the smallest perimeter. So I'm going to start by dragging the base greater, just like I did last time. And notice that is not minimizing my perimeter. It's just making it get bigger. So this is something like, let's say a farmer has a set amount of fencing, and he wants to create the greatest possible area for his cows to roam. Then I would want to again, and if you notice, where is it? And now it's starting to go away. Okay, now it's starting to get bigger again. So it's actually going to be right in here. And it's actually the same as it was for our other figure. And this one's a little bit harder. It's not actually showing it to you. But it's actually when the figure is a square. That will give us the lowest perimeter. Okay? So it's we're going to have the greatest area, we're going to have the least perimeter for a set area when again the figure is a square. Okay? So in order to minimize the perimeter of a figure, create a square create a figure that has the same base and height. Okay? And again, that is going to be a square. The figure will be a square. So let's say that I tell you that I want to create an area of 20. Let's do 36. 36 square feet. Okay, that's what I want my area to be, 36 square feet. What's going to be each side of my square if I want to have the least amount of fencing for my area that I want? It's going to be a square. So a 6 and a 6, square root of 36 basically, is going to give me the smallest amount of perimeter for a set area of 36 square feet. Alright, so tomorrow we're going to be doing a little bit of these in class and practicing these. So come prepared to practice these. You should probably have written these down. You can also rewatch this video if you need to. But we're going to be talking about perimeter and area of rectangles tomorrow. See you then.